Hi everyone, and welcome back to another one of our instructional build videos. On this build video, we're going to show you how to wire up your WorkBee 1050. It's going to be all inclusive, guys. We're going to have the assembly for our micro limit switches as well as our drag chain. We're also going to be showing you how to assemble your open case for your controller board, and we're also going to show you how to configure your software. So all your firmware is going to be uploaded to your controller by the end of this video. Now let's go over some of the highlight points of this kit. So our first highlight of this kit is going to be our LED light ring. This is going to illuminate your whole workspace. Definitely really convenient for any time of the day. Another nice addition to this kit is going to be our drag chain. As you can see here, we've assembled it using the OpenBuilds modular system, using our single L brackets to give you this nice sleek look. Low profile, definitely nice addition for wire management. Also, we have our micro limit switches that are going to be included in this kit. All the components that you see there are going to be included in your kit, and we're going to have our micro limit switches set up for a homing cycle. And last but certainly not least, we have the OpenBuilds open case, which conveniences the builder to mount your controller to the back of your machine, which is awesome, guys. Super convenient. All your wires are coming to one unit, and as you can see, our fan's running currently, keeping our controller completely cool. So now that we have all the highlights pointed out in our kit, without further ado, let's go ahead and get started. Alright, for this first step, we're going to be assembling our 4-conductor wire to our female connectors. In this step, we're going to require 2 of our 4-conductor wires at 3 feet. We're also going to need 2 at 7 feet. In addition to that, we're going to have 4 of our female connectors, and also included in this kit is going to be your male connectors, which, as you can see, I've already connected these to each one of my motors. So if you had the long extension lead, basically going to just snip off the excess, strip it down, and you're going to connect it into your male connector as you see here. So it's going to be red, green, blue, and yellow, and these are the coil pairs for these motors specifically. So to test out the coil pairs on each motor, I'm going to go ahead and give you an example. So each motor is going to have 2 coils. So we have coil pairs that are going to build resistance in the motor when you connect the 2 wires together. So in these motors in particular, we're going to have red and green, blue and yellow. So connecting red and green, you're going to find that your flexible coupling is going to grind. So you hear that? That's the resistance in the motor. So that's how you know that's a coil pair. Same with blue and yellow, you're going to hear that grind. So if the pairs of wires were not a coil, let's say like blue and green, if we connect those, no resistance in the motor. So we know that's not a coil pair. So if you're following along with this video and you do have the motors with the leads, this is how you're going to order your coils. Red, green, blue, and yellow into your male pin. So let's go ahead and connect that. And we're also going to do that for every single one of our motors. So we have our Z-axis along with our Y and our A and X axis. Alright, now for the 4-conductor wires being assembled to the female connectors, we need to make sure to correspond the wires to each color that's indicated on our coil pairs. So red, green, blue, and yellow. If you connect your female connector, you'll see that we're going to work from right to left, red, green, blue, and yellow. So that's exactly how we're going to hook up our 4-conductor wires. Now, for those of you that have the new style of motor, which is going to be already assembled with the male connectors, this style of motor has different coil pairs. Now these are already paired off for your convenience. So as you can see here, if we're working left to right, it's going to be red, blue, green, and yellow. So if you have these motors attached to your machine, this is going to differ. So as you can see, the coil pair colors are different. So you need to focus on that, make sure that you do have the correct motor, because we want to assemble this correctly. So this motor in particular, if we go ahead and connect the female connector, you'll see that our wires are going to go in this order from right to left. Red, blue, green, and yellow. So that's exactly how you would hook up your 4-conductor wire to this female connector if you had these motors. So since we have the old style motors with the extension leads, we're going to go ahead and assemble these in the direction I just mentioned. So red, green, blue, and yellow. If you do have the new style of motors, you need to focus on making sure that all of the colors correspond to each other. Now when we get to our controller board, I will also show you both ways, so for both motors, so there won't be any confusion there. Alright, so let's go ahead and assemble these to our female connectors. So taking each wire, I'm simply going to twist the wire ends to make sure that they're all together. And on each female connector, you need to make sure that you loosen all the pins. As you can see, the metal inserts in here are fully to the upright position. We need to loosen all of those so they can accept the wires. Alright, and from there we're going to start with our 3-foot cable here, and this will be for our y-axis. So from right to left, since we're matching up with these motors, it's going to be red, green, blue, and yellow. So we'll start off with red and green first. And next we'll do blue and yellow. Alright, give that a tug. Make sure that those are fully inserted. I like to stick the insulation all the way into the connector because I don't want any loose stragglers connecting to another wire. It could cause a short in your board, so make sure that those are fully inserted. That looks good. Let's go over here to our y-axis. If we're facing the back of the machine, be on the right side, and let's go ahead and make that connection. And as you can see here, we have red, green, blue, and yellow. All of our wires do correspond. So if you have that other style of motor, make sure that your wires correspond to each other. So now we're going to continue on to our next 3-foot wire. This will be for our A-axis. This will be right here on the left side of the machine if you're facing the back. And let's go ahead and assemble that the same way we did the other. Alright, coming over here to the A-axis, we're going to make that connection. Once again, all of our wires do correspond. Perfect. So let's go ahead and move on to our 7-foot wire. And this will be for our X-axis. Both of these are 7 feet, so it's up to you if you want to do the Z-axis first. Alright, we'll connect this to our X-axis. Alright, moving on to our last wire here. This will go to our Z-axis. Alright, and go ahead and plug this into your Z. Alright, perfect. So now all of our motor wires are connected. Once again, just a reminder, make sure that you have the wires corresponding to your motor specifically. So if the coil pairs differ, if you have the new motors, make sure that you wire that to correspond with the colors. But alright, this looks great, guys, so let's go ahead and move on to the next step. Alright, so moving forward here to the next step. On this step, we're going to go ahead and rotate our machine 180 degrees. I want to be facing the front of the machine for this assembly. So on this assembly, we're going to be assembling our LED light ring to our router spindle, which I've detached from my Z-axis. We're also going to be assembling our micro limit switches. So we're going to need 3 micro limit switch kits. You can see I have 2 here already assembled in a horizontal configuration. And what I mean by that is the micro limit switch is placed horizontally on the micro limit switch plate, and that will be for our X and Y axis. And then also you'll see I have one broken out. So this is what you should see in your kit. Micro limit switch plate, 2 of your M3 self-tappers, an 8mm screw, slot washer, drop-in T-nut, and 2 of your spade connectors. The spade connectors are going to be attaching to your wire, and that's another addition that you're going to need for this step is our 2 conductor wire here. We're going to have 4 sets at 7 feet, and as you can see I've already got 2 with the spade connectors already connected, and I'll go over how to clamp those into place on our 2 conductor wire right here. So starting off, we're going to go ahead and assemble our LED light ring to our router spindle mount. So rotating this to the back, we're going to go ahead and take off our black angle corner connectors. Alright, and let's go ahead and grab our LED light ring, and we're going to place it onto our router spindle. And from there, we're going to use our black angle corner connectors to mount to the router spindle and hold our LED light ring into place. So once you have that placed, let's go ahead and insert our 8mm screws back into our router spindle. We're going to be using these two holes here on the furthest ends. Alright, once you have that complete, we're going to go ahead and place this back onto our Z-axis. As you can see, I still have my points of reference from the mechanical portion of the build, so that's exactly where I'm going to align my router spindle back to the Z-axis. So let's go ahead and put that into place. Alright, and once we have that into place, let's go ahead and move on to our micro limit switches. So these two are going to be assembled in a horizontal configuration. And like I said, they're going to be for the X and the Y axis. This is going to be for our Z axis, which we're going to assemble in a vertical configuration. So this is going to be placed up and down on the plate. And another thing to take notice too is our symbols here, which indicate our common, normally open, and our normally closed. So our common is going to be our negative, it's going to be the common ground. Normally open is going to be our positive. So this is the configuration we're going to use. Our common and normally open. The normally closed, we're not going to worry about on this step. If you want to configure your micro limit switches differently, you could incorporate the normally closed. But for this specifically, we're going to work on a homing cycle. So common and normally open is all we're going to use. So let's go ahead and assemble this to the plate. We want to make sure that these symbols are facing up so we can see where we're plugging our connectors into. And then we're going to take our M3 self-tappers and we're going to screw this micro limit switch into place. So I'm going to go ahead and place those now. And from there we just grab our M3 ball driver and screw these into place. Alright, and from there we're going to take our 8mm screw, run that through the hole. Take your slot washer, making sure the flat end is facing away from the plate. And then we're going to thread on a drop-in T-nut. Alright, and that is what your micro limit switch kit should look like assembled. So for the spade connectors, as you can see, I've already got a couple of these configured onto my wire. Basically stick the wire through and clamp it. I'll go ahead and show you on the one that's bare. So what I like to do is take each end of the wire and fold it in half to give it some bulk. That way you have a nice connection in your spade connectors. So from there you take one of your spade connectors and slide it onto the wire. And you should see the wire sticking through slightly. From there I'll grab a crimp, or wire strippers usually have a crimp on the end. And then we're going to go ahead and press down onto the spade connector like so. Make sure you put force on there. You want to make sure you get a solid connection, just like so. Give that a tug, make sure it is fully inserted. That looks good. And then we'll do the same for our opposite wire here. Alright, perfect. Solid connection there. That looks great. So now we have our spade connectors attached. So do that with your 2 additional wires here. And then we're also going to have our LED wire. So it's also 2 conductor. We're going to go ahead and place that into our LED light ring first. So grabbing our flathead, we're going to loosen these pins here on the LED light ring. And on the bottom you have indications of which one is positive and which one's negative. I'm going to go ahead and show you now. We have red, which is our positive, is going to be on the right side. Black, which is negative, is going to be on the left side. So let's go ahead and insert our wire. And once you have it fully inserted, tighten it down. And we'll take the excess and throw it over our x-axis. Don't worry about the mess back there, guys. We're going to label all of our wires. So definitely don't concern yourself with the mess. It's going to be organized shortly. Alright, so now moving on to our micro limit switches. Let's go ahead and start here with our Z-axis first. So here on the bottom you're going to see that our wheel is almost bottomed out. I'm going to bring my Z-axis up slightly, just using the flexible coupling here to rotate it. And once it bottoms out, I'm going to place my micro limit switch to where the pin activates on this hex nut here. So let's go ahead and configure our wire to this micro limit switch. So remember that red is going to be to our normally open and black to our common ground. So go ahead and slide on your spade connectors. And once again, red to normally open, black to your common ground. Alright, that's perfect. So now we're going to go ahead and place our micro limit switch here on the front slot of our 250 C-beam. And I want to place it to where my micro limit switch activates when it hits this bottom position. So just like so. So as I bring my Z-axis down, it releases the switch, and when I bring it back up, it's going to activate the switch. So that's perfect. So we'll take the excess and throw it over to the back of the machine. And I like to keep the micro limit switch and the LED light ring on the same side. That way I can organize my wires accordingly. We're going to use a slot cover here to keep everything nice and tidy. It's going to look exceptional when we're done, guys. Alright, so let's go ahead and move on to the horizontally configured micro limit switches. We're going to go ahead and take one of our wires at 7 feet. All of these are 7 foot, so don't concern yourself with which one is which. The main thing we need to focus on is making sure that these are configured correctly. So black to common, red to normally open. Alright, and this one here we'll go ahead and place on our x-axis. So in the back channel of our C-beam, which is going to be the top channel here of the C configuration in the C-beam, we're going to place our x-axis micro limit switch. Now this needs to be on the left side because our homing position is going to be to the left front position. This is always a starting point for your machine. We'll go over that further in the software portion of this build. But make sure that you configure this to the left side. So taking our M5 ball driver, we're going to align this x-axis micro limit switch with our y-axis plate. Once our gantry moves over, our travel has ended. So we don't want our micro limit switch to be past this point, because at that point your machine will ram into this plate. So let's go ahead and configure this in line with this y-axis. Alright, perfect. So now when our X gantry moves all the way to the left front position, it's going to activate your pin with the plate. So that's excellent. Now, just want to go over this with you guys as well. These micro limit switches are modular, so you can configure them any way that you like. We're just giving you an overview of how we're going to connect this and how we're going to assemble our micro limit switches for a homing cycle, but it's definitely open to room to expand and to mod it the way that you like. So moving on to our y-axis micro limit switch. Once again, our red wire is going to be to our normally open and our black to our common. Alright, so this is going to be for our y-axis micro limit switch. We're going to go ahead and place this in the bottom channel of your C-beam. Alright, and once the Y gantry comes forward, it'll activate this pin for your homing cycle. That's perfect. So we'll run this over with the rest of the wires. And this is starting to come together, guys. Next step, we're going to go ahead and organize our wires. So let's go ahead and move on to the next step. Alright, moving on to the next step here. As you can see, I've went ahead and rotated my machine 180 degrees so we can label all of our wires. So in this step, we're going to require some blue masking tape, painter's tape, and a permanent marker. And what we're going to do is label each one of these wires according to the point of origin. And that way it's simple. Once we wire these through the drag chain, these things can get convoluted, so we really want to make sure that we label everything correctly. That way we can correspond the wires to our controller board. So let's go ahead and start off with our LED light ring, which is located right up here on the front of the machine. So what I do is I just grab a piece of painter's tape here and I wrap it completely. Now if you were to flag this with the tape, it is easier to write on, but it will rip in the drag chain, so make sure that you wrap this all the way around the wire. Alright, perfect. And I'm just going to label this one LED. And let's move forward to our Z-axis micro limit switch, which is going to be located on our Z-axis. And we're going to label this one ZM for Z micro. So moving right along, let's go ahead and grab our Z-axis motor, which is located right here. And we're going to label this one Z. Alright, moving to our X. So like the Z, we're just going to label this one X. And you can also tell which one's a motor, a micro limit switch, or LED light ring based on the conductor wire. So this is 4 conductor wire, 2 conductor wire for every other electronical point. Alright, moving right along, go ahead and grab your Y-axis micro limit switch, which is located here on the left side of the machine if you were to face the back. And we're going to label this one YM. Moving right along, let's go ahead and grab our X micro limit switch, which is located here on the right side of the machine if you were to face the back. And we're going to label this one XM. Alright, moving right along, we're going to move to our A-axis motor, and we're going to label this one A. Alright, and last, our Y-axis motor, and we'll label this one Y. And that concludes our labeling of the wires. So let's go ahead and move on to the next step, guys. Alright, moving forward here. So on this step we're going to be assembling our X-axis drag chain to our X-axis. So in this step we're going to need our drag chain at 500 millimeters, our 500 millimeter slot cover, which I've cut down 80 millimeters. So that's going to leave you with 420 millimeters. So it's a good place to start, guys. So go ahead and cut that down to 420 millimeters. And the purpose of cutting that down is we need to fit this into the track of our 520 by 40 rail. And this is where our X-axis micro limit switch is going to run. So in addition to that, we're going to have 2 of our 8mm screws, 1 of our M5 25mm screws, 1 9mm aluminum spacer, a single L bracket, 2 M3 T-nuts, and 1 M5 T-nut. Our tooling for this step is going to be our M5 ball driver and our M3 ball driver. So let's go ahead and get started here. First, by loosening one of the ends of our 20 by 40, we're going to have to slide this out slightly to slide our M3 T-nut in, and this is where our drag chain is going to mount. So let's go ahead and loosen these 2 screws here. Alright, and then we're just going to pop this 20 by 40 out. If need be, you can use a lubricant such as silicone to help maneuver this beam out, but generally it comes out rather easy. You can also loosen the screws on the other end or in the C-beam in order to remove this rail. But for this situation, all we need to do is pop in an M3 T-nut. So let's go ahead and slide one of our M3 T-nuts into the 20 by 40, making sure that the flange side here is facing down. And then we're going to slide our 20 by 40 back into the plate here and mount it. Alright, once you have the 20 by 40 in place, we're just going to put our screws back in. And let's go ahead and tighten these down. Alright, perfect. Once you have that back in place, we're going to go ahead and move on to the mounting of our drag chain. So the first thing we're going to check is our configuration on our drag chain. We want to make sure that each end cap is mirroring each other. So just like so, that looks great. So basically one end is going to lay on the track of our cable tray, and the other is going to mount underneath our single L bracket that we're going to place in this center hole here in between our wheels. So let's go ahead and grab our single L bracket, making sure that the spacing that's closest to the edge here is going to mount to our carriage. So let's run our 25mm screw through, add your 9mm aluminum spacer, and grab your T-nut. And we're going to go ahead and run this through our X carriage, and we're going to tighten it to our M5 T-nut behind the X carriage assembly. Alright, make sure that's nice and tight. And obviously you want to make sure that this is straight as well. Alright, that looks excellent, guys. So let's go ahead and move on to our drag chain. So now that we have this configured in the right position, what we're going to do now is run all of our wires through the X-axis drag chain before we mount it. So that's going to be our LED light ring, our Z-axis micro limit switch wire, along with our Z-axis motor wire. So let's go ahead and find the ends of each one of these wires. And once you find the ends, what I like to do is take either masking tape, painter's tape, or anything that can secure these wires. And this is going to be for ease of assembly going through the drag chain. So what I'm going to do is just tape these ends in a bundle. And that way the wire doesn't snag on the drag chain when being forced through. So let's go ahead and run these wires through a drag chain. Alright, and once through the other end, I'm just pulling out the slack now. What I like to do is leave some slack here because we're going to organize these wires with a slot cover, and they're going to hang over our X carriage like so. So that's about enough slack there. So from there, I'm going to take the additional lengths of wire and I'm going to run it through our Y-axis plate here on the left side, just like so. Be careful with the edges here on the square hole, because it will strip your wire. It's very sharp. Alright, and once we have all of our wires through the drag chain, we're going to come over here to our X-axis micro limit switch, and we're going to run this through our 20x40, but we're also going to run this underneath our drag chain. So right here at the end of the drag chain, we're going to pop it through this hole to meet with our additional wires, because all these wires are going to run through our Y-axis drag chain. Alright, once again, leave a little slack here, just in case we want to reconfigure our X-axis micro limit switch. So just leave a little slack right here in the track. That way we don't put any pressure on the micro limit switch. Alright, so that's looking good so far. So now let's go ahead and grab our slot cover that we've cut down. So remember, this is going to be 420 millimeters. And we're going to run this through the top of our 20x40. And this is going to secure our X-axis micro limit switch. So I just start at one end and work my way down. Alright, so once the slot cover is in place, we're going to go ahead and mount our drag chain. So first, here at the left end, I'm going to go ahead and grab one of my M3 8mm screws. I'm going to run it through the center of my drag chain, the center hole here. So that's the hole we're going to use. And let's go ahead and mount that to our M3 T-nut over here. Alright, excellent. So now, the same thing with the top portion. We're going to mount this underneath our single L bracket here for that nice low profile look. So once again, we're going to use the center hole. Just go ahead and grab your M3 8mm screw. What I like to do is just put it on the end of my ball driver and push it through. From there, I'm going to grab my M3 T-nut and we're going to fasten it into place. Alright, perfect. So check that out. We've got our X-axis drag chain assembled. Perfect example of the OpenBuilds modular system. Once again, for the win here, we have a single L bracket, spacer, M3 T-nut, completely configured onto our drag chain. Simple solution. This is awesome. Alright, so now that we have this assembled, guys, make sure we have some slack here. Like I said, we don't want to pull this all through our Y-axis drag chain and then find out we need more slack. So we're going to go ahead and pull that. So making sure we have a decent amount. That looks good. And we will tidy this up later on with some zip ties and make sure that everything's organized here. But this looks excellent, guys. So let's go ahead and move on to the next step. Alright, moving on to the next step here. As you can see, I've rotated my machine 90 degrees to give us access here to our Y-axis. We need to assemble our Y-axis drag chain on this step. So we're going to require a 1000mm drag chain for our Y-axis, 2 of our single L brackets, 2 M3 T-nuts, 1 M5 T-nut, an end cap, 2 of our M3 8mm screws, 1 of our M5 15mm screws, and our slot cover. So this slot cover is going to come at 1000mm. I've cut 100mm off in order to fit in the slot of the C-beam on our Y-axis. So go ahead and cut that down to 900mm. And let's go ahead and get started here. First, by taking off our end cap here towards the back of the machine where our motors are located. This double end cap has got to come off, so we're going to go ahead and loosen these screws. Alright, so 2 of our self-tapping screws we are going to keep because we're going to utilize these. So go ahead and put this to the side, the double end cap. We're not going to need it. Alright, from here we're going to go ahead and grab one of our single L brackets, making sure the hole spacing that's closest to the edge here is going to mount to our 20x40 here on our base. So grab one of your self-tapping screws, and we're going to mount that into place on the bottom section of the 20x40. Alright, and let's make sure that that is straight. So use your ball driver if need be. Alright, perfect. So now for this top portion here, we're going to just go ahead and place an end cap. So use the self-tapping screw in your end cap, and let's place this. Alright, so let's go ahead and move on to our drag chain. I want to make sure that it's configured properly. So once again, we want mirroring ends here on the drag chain. So that looks great. If you do need to rotate these, all these links are modular. So you can pop these caps out and reassemble them. You can grow it and shorten it to any length that you desire. So pretty cool. We're going to go ahead and take the back end of the drag chain here. I just want to show you how this is going to set on this Y-axis. So using the left holes here of the drag chain, so as you can see right here, the left hole is what we're going to use to mount to our single L bracket. The other end is going to mount underneath the single L bracket, similar to the X-axis. And the single L bracket is going to be placed right in this hole underneath our motor. So let's go ahead and assemble that first. Once again, focusing on the hole spacing here. The spacing that's closest to that edge needs to mount to this hole. So let's make sure we get that right, guys. So taking the 15mm screw, we're going to run it through our single L bracket. Grab your M5 T-nut, and this is going to secure it on the back. So this hole here is where we're going to place our screw. Let's go ahead and place that through. And from there, we're going to tighten down our T-nut. Alright, make sure that's nice and tight. And then we're going to straighten it out with our ball driver. Alright, so from here, let's go ahead and run our wire through our Y-axis drag chain. So all of our wires, except for our Y-axis micro limit switch, is going to be ran through the drag chain. And what I did, similar to the X-axis, I bundled these in our masking tape. Just really helps by feeding these through. So let's go ahead and feed these wires through. Alright, so once you have all the wires pulled through, once again we want to leave a little slack here. That way we can mount this drag chain. So using the left hole here of the drag chain, we're going to mount that from underneath our single L bracket. So let's go ahead and grab one of our M3 8mm screws, and we're going to place that through the drag chain. And then we're going to use our M3 T-nut to tighten it into place. Alright, perfect. So now that that's configured, we're going to come here to the back of the drag chain. Once again, using the left hole here, let's just go ahead and drag our machine back slightly. We're going to go ahead and place our 8mm screw through. And let's tighten down this screw with our M3 T-nut. Alright, let's push the machine back. Alright, and our additional lengths of wire can run towards the back here, so they're going to be attaching to our controller board. But now the drag chain is assembled here on our Y-axis. It's looking exceptional, guys. So let's go ahead and place our slot cover here into our Y-axis channel for our Y-axis micro limit switch. So what I'm going to do is run this wire through this channel behind our plate. Alright, and from there we're going to take our slot cover and place it into the channel to cover this micro limit switch wire. What I like to do is tuck this wire behind the micro limit switch plate. That way there's no interference when our gantry system comes back and forth. So just make sure that that wire is out of the way. That looks great. As you can see here on our opposite end, we have plenty of room here for our micro limit switch wire. So we're going to run that to the back of the machine as well. Alright, and that is our Y-axis drag chain assembly. It's coming along nicely, guys, so let's go ahead and move on to the next step. Alright, so moving on to the next step here. On this step we're going to be assembling our controller board. So for this video we are assembling our Xpro controller. Just a couple things I want to show you on the board here. Each one of our axes is going to be indicated. So as you can see here we have A, Z on the opposite end. We have our Y and X. And you can also see that we have the limit switch indication here as well. So it's really convenient for labeling our wires and making sure that they correspond to the right section. So make sure you pay attention to which motor you're hooking up your wires to. In addition to that, we also have inputs for our fan. So right here is going to be where the fan's going to hook up. We also have our outputs. So this would be for motors, coolant. So the motor tool would be for spindle, laser. You can set up any type of tool here, which is really nice and convenient. We have our serial port and of course our power input. So let's go ahead and get started here. So what I like to do is place my controller on this card that comes with your Xpro. That way we don't have any debris collecting on the bottom of this controller. So let's go ahead and grab our first wire here. This one is our Z micro limit switch. So right here we're going to have our Z motor. So our Z micro limit switch is going to correspond to the limit switch section of the Z motor. So the first thing you're going to do is loosen all of these pins, which you can see I've already done. These come already tightened, so you just want to loosen those pins so it can accept the wire. From there we're just going to twist these wires, make sure they're all uniform and together, and we're going to stick in red in the left hand side and then black to our ground, which this symbol stands for the ground here. So go ahead and insert those wires. Alright, perfect. So what I like to do is make sure that the insulation fully inserts into the slot. So as you can see, my wires are fully inserted into this input. It's very important for a good connection, and you don't want any cross connection between your wires. It could cause a short in your board. So be very careful when hooking these wires up. You want to make sure that you do it properly. Alright, so our micro limit switch is hooked up. Let's go ahead and move on to our Z motor here. Now for the motors, this is going to be for the leads that we had, the extensions on our motors. So red, green, blue, and yellow are coil pairs. What we're going to do is translate that to our Xpro controller. Now if you had the other motors, which would be red, blue, green, and yellow, then you would translate that to your controller. Now I'm going to go ahead and give you an example of that. So if you want to go ahead and pause the video so you can see that these wires correspond to each motor, go ahead and do so. You want to make sure that these wires line up exactly how I have it here on the Xpro. So you can see red, blue, green, and yellow. And these translate to the motors with those coil pairs. So if you have the motors that already have the male pins attached, this is exactly how you're going to hook up your Xpro controller. The micro limit switches, you can follow along this video, and it's going to be the same exact way. Red and black. It's going to hook up into your limit section. So make sure you do translate that correctly to your Xpro according to which coil pairs you have on your motors. Alright, and for these, since we had the lead extensions, it's going to be red, green, blue, and yellow. So we're going to translate that to our Z motor, just like that. So we're going to go ahead and insert red and green first. Alright, so we have red and green inserted. So next is going to be blue and yellow. Now if you need any additional information on how to wire this up, we do offer diagrams, and I'll put the link in the description. It's all on the forum for this build in particular, and we show you an exact diagram of how this needs to be hooked up. So make sure that you reference back to that if you do get confused. But throughout this video, I'm going to make sure that I show you each way to hook this up. So if you need to pause the video just to get a better look, go ahead and do so, and then we'll move forward from there. So next we'll do blue and yellow. Alright, and make sure, once again, I can't stress this enough, make sure that all your points are fully inserted into your pins here. It's very important. So now we have our Z motor hooked up. Let's go ahead and move on to the next section, which would be our A-axis motor. Let's go ahead and find that labeled wire. So once again, red, green, blue, and yellow. And the A-axis is a slave to the Y, so we're not going to have a limit switch section. Only the Y-axis will have that limit switch. So we're just going to go ahead and insert the same way we did the Z. Alright, give those a tug, make sure all those wires are fully inserted. That looks good. So now we're just going to rotate our controller around so we can access our Y and X motors. So let's go ahead and locate our Y-axis motor. Alright, and next we're going to locate our Y-axis micro limit switch. And once again we're going to insert red and then black. Alright, and let's go ahead and locate the X-axis motor. Alright, and let's locate the X-axis micro limit switch. Alright, perfect. So now that we have our wires connected to our controller, we are all set. Make sure, like I said on the beginning of this step, if you have the motors that have the male pins already attached, make sure that you wire up your Xpro just like I show you here. So that coil pairs are going to be red, blue, green, and yellow, and it's going to translate across each axis. Alright, so let's go ahead and move on to the next step. Alright, moving on to the next step here, we are going to be assembling our open case. So we're going to need to go ahead and gather these parts. We're going to need 2 of our open case plates, our 24-volt brushless fan. We're going to need 4 of our hex standoffs, 12 of our M3 20mm screws, 4 12mm screws, 2 of our 15mm screws, 8 M3 T-nuts, 4 precision shims, 2 drop-in T-nuts, 2 of our 3mm aluminum spacers, and 2 slot washers. Our tooling for this step is going to be our M5 ball driver and M3 ball driver. So let's go ahead and get started here first by grabbing one of our plates. We're going to insert 4 of our 20mm screws through each one of these corners. So let's go ahead and insert these screws now. And from there we're going to take our hex standoffs and screw them into place. And what I do is I just hand tighten these. You don't want to over tighten it because it will strip the plastic. So that's good right there. And let's do that for our 3 other corners. Alright, perfect. So now that we have our hex standoffs in place, we're going to go ahead and take our Xpro controller and we're going to place it on top of this plate. And from there you're going to see that these holes line up with the controller. So let's go ahead and run our 12mm screws through. Alright, and from there, just going to place our plate on its side, and we're going to hand tighten our M3 T-nuts to each screw. So once you have your M3 T-nuts in place, we're going to go ahead and run our 15mm screws through these two holes next to our hex standoffs, and this is going to be for our mounting process to our 20x40 here on our base. So take the M5 15mm screws, we're going to run them through each one of these holes. Alright, and from the back, we're going to add our 3mm aluminum spacer, then our slot washer, making sure that the flat side of the slot washer is facing away from the plate, and add drop-in T-nut. We're just going to thread that on. Alright, and we're going to repeat the same process for our left side. Alright, perfect. So now let's move on to our next plate, and this is going to mount our fan. So our fan is going to mount to the outer holes here on the case. So where our controller mounted, go down one, and that's where our fan is going to mount. So taking our 20mm screws, we're going to run them through each one of those outer holes. From there, we're going to place the case on its back, and we're going to add our precision shims to each screw. From there, make sure that your fan is configured properly with the sticker facing you. So let's go ahead and mount our fan. And then from there, we're going to add our M3 T-nuts on top. Alright, perfect. So from there, our 4 20mm screws that are left over, we're going to carry on into the next step. I want to leave this case open for you so we can see the power wire hook up to our Xpro controller, as well as some additional things that we're going to do to this case. So let's go ahead and move on to the next step. Alright, moving forward here to the next step. On this step, we're going to be assembling our power supply unit, as well as configuring it to our controller. So we're going to need to gather these parts. We're going to need our power supply unit, as well as our 2 power wires, one being for the power supply unit to an outlet, and then our power wire that's going to power our controller board. In addition to that, our tooling, we're going to have an M5, M3 ball driver, Phillips, flathead, and some snips. As you can see here, I have one lone zip tie. You're going to receive 15 in the kit. We're going to use one, and that's to strap on our power wire so it doesn't pull loose. If there was any type of pulling motion on your controller board, the zip tie will absorb that force. So let's go ahead and get started here. First, with our power wire to our power supply. You'll see on the opposite end, once you have these wires stripped, you're going to have green, white, and black. Now you can have green for ground, white for neutral, black for your line, and that corresponds to your power supply. Here we have our ground, neutral, and line. So let's go ahead and grab our Phillips, loosen these 3 terminals, and we're going to go ahead and insert our wires just like so. So green on the left, whites are neutral, and blacks are line. Insert them fully into the terminals and screw down. Alright, make sure that those aren't coming loose. That looks great. So let's go ahead and move on to our power wire for our controller. Now for this, on the power supply, you're going to have an output section. You're going to have a positive and negative section. So 3 and 3, 6 in total. We're going to use our positive and our negative here. So red is going to be our positive, black is going to be our negative. Let's go ahead and insert these wires. And then tighten down. Alright, give that a tug. Make sure that those aren't going anywhere. That looks good. So now we're going to go ahead and relay this to our controller. So same with our positive and our negative. Here on our controller, you'll see that we have indications of our ground and our positive. So ground is going to be our black, red is going to be our positive. Just loosen these pins here, and we're going to insert these wires and clamp them down. Alright, give that a tug, make sure that those aren't going anywhere. That looks good. So now from here, we're going to go ahead and strap down our power supply wire. So on our open case, you're going to see 2 of these slotted holes here, and that's for our zip tie. So let's go ahead and run our zip tie through. And let's go ahead and tighten this down onto our power wire. Alright, make sure that's nice and tight. Then we're going to take our snips here, and we're going to cut off the excess. Alright, perfect. Now that we have that configured, we're going to move on to our plate. So with our fan attached to this plate, what we're going to do is go ahead and plug in our fan. So with the positive and the negative on the input here, we're going to line our red with positive, black with negative. Just like so. Alright, so what we're going to do now is go ahead and bundle these wires together. You always have the option too to snip off the excess if you want. That way you have a direct point to your controller. I like to keep the excess just in case I want to configure this differently. If I want to move my controller to the opposite side, center it, mount it on the side, it gives you options. So what I'm going to do is just go ahead and take any of my excess and I'm going to bundle it together and zip tie it. Everything but my LED light ring. So this is going to be wired to our power supply unit, so we're going to leave that off to the side for now. Alright, so once I have my wires bundled, I'm going to grab one of our zip ties. Let's go ahead and secure that. I'm going to snip off the excess here. Alright, from there I like to take the bundled wires and align it to the bottom of the open case. That way we still have circulation of cool air onto our board. That's very important. So I place it here at the bottom, and from there I'm going to stack on the top portion of the case. And then we're going to lock it in with our 20mm screws. So let's go ahead and get that done. Alright, perfect. So now that we have our screws mounted, we're going to go ahead and place our open case to the back of our machine. So on the bottom track of our 20x40, we're going to mount our drop-in T-nuts and screws. As you can see, we have access holes here on the front face of the open case. And let's go ahead and mount that into place. Alright, perfect. It's looking really sharp, guys. Alright, so now that we have that mounted, we're going to go ahead and grab our LED wire. As you can see, it is longer than all the rest of our wires, and the purpose of this is so you have options to mount your power supply. So wherever your power supply unit goes, you'll have that additional length on your LED light ring, so you don't have to worry about being stuck in one position. So let's go ahead and grab our LED light ring here. And on the output section of our power supply, we're going to go ahead and wire up our LED light ring. So on these 2 terminals, I'm going to go ahead and configure this LED light ring. So positive with positive and negative with negative. Alright, perfect. So now that we have that configured, now we're going to go ahead and bundle our additional wires together. So all we're going to need for that is our zip ties. So first I'm going to go ahead and start here on our Y-axis motor. So what I like to do with the connector is run the zip tie through. And once you run it through the connector, I zip tie this down, making sure that this connection remains so it doesn't come loose at all. Just like so. Then we're going to snip off that excess. And then our additional wires here coming out of our Y-axis drag chain. I'm going to bundle these together and zip tie them as well. And all of this organization is completely up to your preference. We're just showing you a good example of how to organize your wires, but this is completely up to you. You have the zip ties, so the way that you want to organize it based on your configuration is completely up to you. Completely modular, guys. So what I like to do now is go ahead and zip tie this bunch of wires together as well. Just keep everything nice and uniform. And also on this side, I like to secure the connector here to our 40mm aluminum spacer. And that's so we don't have to worry about this system dragging if we were to move the machine. Alright, now working our way over here to the right side. Once again, we're going to go ahead and zip tie this connector. Alright, from there, we're going to have remainders of our slot covers that we cut down for both our X and Y axis. We're going to bring those in. And what I like to do is cut one of these in half, the one with the most length. And from there, I'm going to place this in the track of our 20x40 here, just to keep our A-axis motor in place. Just like so. And then our additionals we'll use on our Z-axis. So this is starting to look sharp here. I like to leave my power wire loose. That way I can configure my power supply any way that I like. If I want to put it on the floor, you can. On the side of the machine, you also can. But for right now, we're going to use that additional length for our configuration. So let's go ahead and come over here to our X-axis. And once again, I'm going to zip tie this connector. Alright, and let's cut off the excess. Perfect. These additional wires here, they look good and uniform, so we're not going to zip tie those. Alright, so now moving on to our Z-axis. Right up top here, we're going to zip tie these together. And what I like to do is split these two. We have our overhang for our Z-axis, but these two I'm going to configure right on the front channel of the C-beam with one of our slot covers. So I'm just going to slide the slot cover in. Alright, from there we're going to zip tie our Z-axis. So right on this connector. Alright, that's looking really sharp. Alright, so once we have that configured, let's go ahead and move on to the next step. Alright guys, so on this next step we're going to be installing our USB cable to our controller board. So we're just going to grab our USB cable and we're going to plug it into the serial port, which is located right towards the bottom of the controller. So let's go ahead and plug that in. And once you have that plug in, let's go ahead and bring this over to our laptop. And let's go ahead and move on to the software portion. Alright, so for the software portion, we're going to go ahead and open up our browser so we can download our machine control driver. So let's open up the browser. We're going to go to OpenBuilds.com. From there, we're going to select the software tab. And right here, you're going to see OpenBuilds Control Machine Driver. That's what we want. So let's go ahead and download that. I have Windows. If you have Mac or Linux, you can select those options. We're going to go ahead and download for Windows. Alright, and once it downloads, we're going to go ahead and select the executable. And here you're going to see a prompt that shows up for Windows Protected Your PC. We're going to go into More Info, and we're going to run anyway. We're going to go through the prompts, and then Install. Alright, and then we're going to finish. And from there, you're going to see your driver did start. Select that. And it's going to open your machine control driver. Alright, from there we're going to check for our COM. Down here there's going to be a selection for COM13. We're going to select that and then connect. And from here, you're going to see Gerbil settings populate. So go ahead and select that tab. And here you're going to have all of your populated values for your firmware in your controller. So these are the values that we're going to input for our machine specifically. So in order to do so, we're going to go back to OpenBuilds, and we are going to find our machine. So this is the WorkBee 1050. So we're going to find that machine, select it, and here's going to be all kinds of different things about the machine. You've got reviews, details, files and drawings, parts lists, and discussions. The forum is a great place for makers. You can ask any question, you get immediate responses. You also get details on the machine as well as different machines that are being developed. Definitely a great resource. If you've never interacted on the forum, please do. It's a great place. You guys will love it. So let's go down to WorkBee 1050 Gerbil settings, and we're going to click to expand. And from here, I'm just going to minimize that so I can copy these values over. So starting at the top here, for 0, we're going to enter in 10. And we're basically just going to follow all these Gerbil settings, and we're going to input them into our machine. So let's go ahead and start with 0. That one is 10. 1 is going to be 255. 2 is going to be 0. So for 3 here, this is going to be step direction invert. So this setting specifically, it might vary with your machine depending on what motors you're using. So this one we will come back to. We're going to test our machine out and check to see if our positives and our negatives are working correctly. And once we find that out, then we can invert which axis is not moving in the right direction. So we'll come back to that one. So 4 is 1, that's going to be enabled. 5 is 0, it's disabled. 6 is also disabled. 10 is 1. 11 we have 0.020. 12 is 0.002. Report in inches, that is 0 as well, so that's disabled. 20 is also disabled. 21 is disabled. Now, if you were to select the default settings here for your machine, which these will be populated, so we have OpenBuilds WorkBee 1050 here actually, so we could go ahead and select that and it would populate the values. You still might need to tweak things depending on your motors and your configuration specifically, but it is a good place to start. It uploads the values identically as what we have on the forum. For 21, that's also disabled. 22 is enabled. We are going to run a homing cycle. We have our micro limit switches hooked up. And here for 21, these are hard limits. We'll go ahead and enable that as well. It's just a good precaution because when you're running a homing cycle, or if you're running your machine and it touches a micro limit switch and you weren't trying to jog it to the full extent, your machine will stop. And then an alarm will be set off and you have to unlock the alarm before your machine can run again. It's definitely a nice safety feature, so we're going to enable that. 24, that's going to be set at 100. 25 is going to be set at 1000. 26 is 250. 27 set at 3. 30 at 1000. 31 is 0. 32, we're not using a laser, so that is disabled. And then we have our steps per millimeter. So now there is a calculator available for your drive system specifically. So if you select the calculator, you can choose which actuator type, motor type, micro stepping type, belt type. Really cool stuff, and it simplifies the process so you get a calculated value at the end of the presets that you choose. So it's really cool. So you definitely can utilize this. We're just going to go ahead and put in our inputs. We know that this is a lead screw driven machine, so we're going to go ahead and enter in our value for that. It's 199.100, and that's going to be for all axes. Alright, on down to 110. Alright, so we have our maximum rate set at 2500. That's perfect. You don't want to go over that, guys. It's definitely a nice fast rate for a lead screw. Actually, you could go lower if you want, if you just want to make sure that your machine is functioning correctly before you bump that up. but 2500 is as fast as I would go for a lead screw. Alright, so going on down, so that's for 110 through 112, they're all 2500. 120, we're going to set that to 150, as well as 121 and 122. Alright, and then our maximum travel. So we have our X, Y, and Z. We're going to start with our X first, and that's going to be at 317. Next is our Y-axis. We're going to input 762. And then our last value here is for our Z-axis will be at 122. And these are all the calculated values for maximum travel on our machines. So now that we have all of that inputted, we're going to go ahead and save to firmware. And it's going to say configuration updated, reset Gerbil. It's going to give an explanation on how it's going to reset the controller. Say yes. Now all your parameters are set up for your machine. So your firmware is uploaded to your controller, and we are ready to go ahead and jog the machine around. Alright, so now we're going to go ahead and power on our power supply. You should see that your machine turns on, your LED light ring is activated, and you'll hear your controller's fan blowing. So now we're going to go here to the unlock alarm state. We're going to go ahead and unlock that. We're going to go to our control, and we're going to go ahead and bump our increments down to 1 millimeter movements because we're going to check our axis for any type of inversion that's necessary. So starting with our X, we're going to go ahead and move this to the right. So the positive movement is going to move towards your Y-axis plate with your X motor attached. So right here. Let's go ahead and jog that. Alright, so there's no inversion necessary for our X-axis. So if we hit negative, it's going to the left. That looks great. So now let's try our Y-axis. A positive movement is going to be back into the field. A negative movement is going to be towards our homing position. So we're hitting positive. Alright, so Y needs to be inverted. As you can see, when we hit negative, it's going back into the field, which it's not supposed to. And positive is coming back to our homing position. So now let's check our Z-axis. Now this one, I'm going to bump down to 0.1 millimeters because I'm all the way at the upright position. I don't want to grind on my lead screw, so the Z actually looks good. So I'm going to bump that back up to 1. And it activated my micro limit switch for a hard limit, so it stopped the machine, which is great. So I'm going to unlock the alarm here. So negative movement is down into the material, positive movement is up away from the material. Alright, so let's go back to our Gerbil settings, and we need to invert our Y. So coming here to step direction invert, we are going to take off the inversion of Y. This is the presetting. And we're going to leave the inversion for Z because the Z was fine. And then we're going to save to firmware. And it's as simple as that. So if you ever have any issues with inversion, just go back to that setting, and it's just a little click, and you have your axis functioning in the right direction. So as we go forward, or a positive movement, the machine is going back into the field. That's exactly what we want. Negative movement, back to our homing position. So that's excellent. So all of our axes are functioning correctly. So now we need to try a homing cycle. Alright, so for the homing cycle, we're going to hit home all. So up at the top portion, you're going to see home all. Now before you do this, we're going to go back to our Gerbil settings, and we're going to check our homing direction invert to make sure that you guys are on the right value. So 3 is going to be the value for our homing direction invert. So it's just going to invert the Z. So make sure you select this one here from your menu, and then save that to your firmware. Now make sure you do that before you hit a homing cycle, because your machine will go in the wrong direction. So that's just another one of those things that we got to check, test out the machine, make sure everything's functioning correctly before we just try to run the machine. This is all troubleshooting, making sure that everything works properly. Every machine will be different depending on how you configure it. These are our presettings for these machines specifically. So the 1050, these values will be correct. If you're running the motors that I'm using, as well as the machine and controller. So let's go ahead and hit a homing cycle. It's going to start with the Z-axis first, and then it's going to work to the X and the Y. And this is going to be our homing position, so it's going to come to the front of the machine. So it finds the limit switches, it backs off, locates them again, and readjusts to the position. So that's awesome. So now we have our homing cycle complete. Our machine is running correctly. So now we're going to go over some more details in this software. So up top here in our tabs, you're going to see troubleshooting. So select that. And here you're going to have end stops. So for your micro limit switches, you can see if they're operating properly before you run a homing cycle. So if I activate one of my switches, I'll activate my Y. You'll see that that one turns on. Not only that, but the alarm goes off. So right here, your alarm went off. That's a hard limit. So if it touches that micro limit switch, your machine's going to stop, which is perfect. It's definitely a nice safety feature. So we're going to go ahead and unlock the alarm. And once again, if you are jogging the machine around or homing the machine and it goes in the wrong direction, you can always revert to stop job in the software or power down your machine. We usually use a power strip, so all you have to do is press a button, your machine will shut off. So just to keep that in mind, safety first, guys. Alright, so our machine is jogging around properly. Everything looks good there. The troubleshooting is definitely a nice place to figure out if your micro limit switches are operating properly, as well as if you have probes. Really cool, very powerful software. So let's go back to the control tab, and here you have tooling options. So you have your tool options for a spindle, you can turn it off, as well as coolant. So these are all outputs on your controller board. We also have a jog widget, so you can scan this code and you can jog your machine around with your phone, which is really cool. Also, we have your folder here, so you can open pre-existing G-code that you might have. It opens up into the machine driver, and you have a G-code editor as well as the 3D viewer. So this 3D viewer is awesome. I love this feature. You get to see your machine working live. You can simulate the toolpath, reset your view, change the orientation. I mean, this is really cool. It's like having your cam built into your machine driver. I absolutely love this feature. Very useful. So, that being said, let's go ahead and run a hello world. So what we're going to do now is go ahead and go back to OpenBuilds. And where we found our machine driver and software tab, we're going to locate our OpenBuilds CAM G-code generator. From here, it's an online application, so we're going to browse to. And if you have worked with this CAM software before, it will recover your last workspace, which is really cool. It saves it. But we're going to start with a new workspace so we can set up our machine specifically. So up here at the top, we're going to select Settings. Select Settings here in that open tab. And now you're going to select your controller. We're using the Spark Concepts Xpro, and our machine is the OpenBuilds WorkBee 1050. So we're going to select that machine, and it's going to upload the parameters for this machine specifically, which is really, really nice. Very convenient and user-friendly. I love it. So here it's going to give you automatic options. So these machines are CNC, so these machines are used generally with mills, so your presetting is going to be to turn the spindle on. We're doing an air cut, so you don't necessarily need a tool, but we'll just keep it in there as this is a setting that's populated after you choose your machine, which is really cool. So let's go ahead and save these settings. All your parameters are correct. You can customize these defaults if you like, if you modified your machine. So let's go ahead and save. And from here, it's going to populate the workspace. So right here is a layout of your machine. Really awesome. You can change the orientation. We're not going to go over too much details in our CAM G-code generator. I'm just going to show you how to open up your Hello World, but we will have future videos showing this CAM software in detail. It's very powerful and an awesome innovation. And on top of that, guys, it's free. It's awesome. All right, so let's go back to our workspace. And right here you're going to see an option for open drawing. We're going to open our Hello World example. And from here it's going to calculate toolpaths. So it's going to do all the work for you here, and it's going to generate your G-code. Alright, so now we see our toolpaths here and our G-code generation. We're going to go ahead and transfer this G-code to our machine driver. And automatically it's going to pull up the 3D view. So as you can see here, we know exactly where our toolpaths are going to go. I absolutely love this. And you can simulate it if you want. Let's go ahead and hit simulate. I'm going to bump up the speed here to 100 times. Like I said, you can change the orientation here. And check that out. That is awesome. You can zoom in. Really, really cool stuff. Alright, so we're going to stop that simulation. And let's go ahead and run this job. But before we do it, we're going to go ahead and set our 0 point. This is very important for any machine. You want to make sure you set your 0 point according to the material that you're cutting. We're not cutting down any material, but we still need to set a 0 point for the machine. That way our machine doesn't bottom out or it doesn't grind on the top for our Z-axis. The same for the Y and the X. You don't want your machine ramming into the sides. So let's go ahead and we're at a homing position now. We're going to go ahead and bump our Y out slightly. We're at 1 millimeter increments here. I'm going to move my X out slightly as well. And then our Z, we're going to go ahead and jog that down quite a bit because our machine's going to act like it's delving down into the material. This G-code is used for cutout. So if you had a spindle and you wanted to cut out some wood, this would cut it out. The G-code is completely set up to work on material. So since we're doing an air cut, we're going to act as if we were setting our machine up for a material cut. So we're going to bring that Z-axis down because it's going to delve down and back up to adjust from each toolpath. So let's go ahead and set our 0 for X, Y, and Z. You're going to see all your digital readouts, your DROs. They're going to 0 out. And now let's go ahead and run this job. So here in the 3D viewer, I'm watching my machine work, as well as watching it to the side of me. This is awesome. Your machine is alive. We've got our machine completely configured. Now it's time to do some awesome projects. Thanks for tuning in, guys. Make sure to subscribe to the channel. We've got more videos coming out all the time. We're innovating constantly, so you definitely want to be kept up to date. So make sure to subscribe, and good luck on all your future builds.